Hello everyone and welcome back to this next lecture in the machines lecture series, and this is where we had left off in the previous lecture where we had simulated a variable load using a variable resistor and a variable inductor. So just to have a look, these were the results that we had obtained. So for example, we had seen that when we change the value of the resistor and inductor, we do get different currents. Not only are these currents different, but they can also simulate a different power factor. So in this way, this is a very basic simulation of a variable load. But however, this doesn't have any of the dynamics of a machine that we would like to simulate once we start simulating in detail electrical machines, because we would also like to know about different oscillations in machines as they start, as they stop, as they accelerate, as they decelerate. So therefore, we are looking at a more detailed model, and that's what we'll start with in this lecture. So as always, before I start the lecture, a little bit of brief background that if you're interested in these kind of video lectures, but you would like something a little more comprehensive, I do have full-length online courses. For that, you can just go over to my website, pythonpowerelectronics.com. That is basically this name of the project, Python Power Electronics, all in small letters with a .com. So once you go to this homepage, you can just have to go to this button called Learn. And this is where all the courses are listed. So for example, the very first course which I have is called Simulating Power Electronic Circuits using Python. And in this I talk about the very basics of how you can simulate an electrical circuit using Python, and especially Python Power Electronics. The next course is Basics of Digital Signal Processing for Power Engineers, and this is more on signal processing, how we can design and implement filters using Python for electrical engineering purposes. The course after that is Simulation of Magnetics for Power Electronics using Python, and this is more on how you can simulate magnetic components like inductors, coupled inductors, and transformers for power electronic applications, again using Python and Python Power Electronics. The next course I have is Control Analysis with Python for Grid Connected Converters, and in this I talk about how we can design, analyze, and implement controllers using Python and Python Power Electronics. I have one more course which is a free course, and this course is Why Specialize in Power Electronics, and this is to talk about the power electronics domain in general and the challenges and opportunities that are available for power electronics engineers. So you can click on the button that are there, and this will take you to the actual course link. So the link for this page is provided in the description for this video. If you're interested, do check it out. So with this, let me come back to the lecture here. So now that I have created this lecture on the basics of simulating our RL load, let me create now another simulation where I will replace this variable resistor combination with a current source. So for that, the first thing I'm going to do, go over to Simulations, create a new folder, and call this Simple Current Source. I'll call this load as well. I mean, you can name it anything you want. So this is my load. So before that, let me go over to my simulation, go back to the main page, go to the circuit parameters, view components, and let me export the parameters, because then I can use these parameters to get started with a new simulation. Go back to the main page, go back to edit control, again configure control, export control. So this will export the parameter and the descriptor for this simulation, which we can use in the next simulation. So with this, let's go back to our main page, and we're pretty much done. We can just go back to the simulation library and we see one simulation. So all I'm going to do, go to the file browser, pick out those files, that is load variation underscore description, which is a descriptor file, RL load and RL load parameters. I'm going to copy it and paste it in this new file. Alright, so let me first rename this. Actually, it can remain RL load because it's just that I'm still simulating an RL load, but I'll be simulating it instead with a current source. So this can remain as it is. So let me go over, create a new simulation, and then call this load as a current source. And I'll just copy this. Now, The time duration can still be 1 second. Integration time step can be 1 microsecond. Time step, I'll make it the same as the integration time step. You can leave it different if you want, not a problem. No need to slice the output. Number of slices doesn't matter. The directory. For the directory, I just come here. Make sure you're in the right directory. That is the new one. Click on this. Go to properties and pick out the parent folder. Go to the web browser. Paste it. Save the simulation parameters, and if you see this page, it means it has been able to successfully add this folder. So if we come over here, close this file, you'll see that there is now a test file. So this test file indicates it is done. It's a 0-byte file. So we are now good to go. So let's go back to our Chrome and let's add the files. So choose file. Make sure you're in the right directory. This is not the right directory. Go to RL load and just click on load circuit or any other name you want. It's the wrong spelling. Save it. We have to process it because this is a new simulation. We have to create the Python objects. There are no errors. We didn't expect any because this is a working simulation. Let's go back to the main page. Edit circuit parameters. View components. We can just upload the parameter file. So make sure you're in the right directory. Go to RL load _ params and click on upload. And we see that the parameters have now been uploaded. So these are the same parameters as we had in the previous simulation. So we are now good to go. So with this, we can just go back to the circuit list and do the same for the control file as well. So we will add the same control file, make sure you're in the right directory, pick out the load variation.py file, and I will just write load variation to begin with. Save the control file, go to configure control and choose load variation descriptor. Upload the file and we have the output. We have the control parameters. So with this, we are now good to go. We can just simulate this as it is. So for example, if I go over to the main page and I click on view output and I click on the run button, this simulation should now be running. So this simulation as it is just a repeat, so that's no use. So what we need to do is let's modify this. So the first thing I'm going to do, I'm going to close it down, go to the file browser and open this new file that I have, which is RL load. Now in this, I'm going to make a change. The change I'm going to make is I'm going to replace this with a current source. So what I'm going to do, I'm going to delete all this and I'm going to put a jump label. What I'm going to say is this jump label is for my new load. I'm going to create the load in another circuit file. Why? Because later on I would like to make this into an induction machine or a synchronous machine or any other kind of machine. So therefore, so I can expand that particular circuit, I would like to start my load representation in a new file. So I will call this load1. You can call this anything. Let me call this current source term1. All right. It is always best to name your jump labels as explicitly as possible so that way when your circuit expands, you don't have to make any changes. So I will call this term2. So it's a 2-terminal component. So I'm going to save this and I'm going to create a new file. And here, let me quickly make the skeletal. Pull it out. And here as well. And pull it out here. So this is now a load representation. What does it need? It needs the 2 jump labels to begin with. So let me go over and copy those. So I can just copy one, that's good enough. Delete this, paste it here. And call this term2. So we are now connecting this to our new system. So the way we're going to do this is, we are going to connect this as a current source. As a current source, the way we do a current source is, You can use a current source model, but a better way to have a current source, and that to a variable current source, is to have a controllable voltage source in series with a variable resistance. So what that means is I'm going to call this controlled voltage source, and I can call this, let's call this current source. I'll call this current source volt, current source 1 volt. I'm probably going too far here in naming, but as I said, try to be as explicit as possible. So now that we have this, what do we need? We need a variable resistor as well. And again, I will call this the same name, that is current source 1 volt. And this can actually be resistance instead of volt, because this is the resistance for this particular current source. Now once this is over, what else do we need? We need an ammeter, because we are controlling this particular branch in order to draw a particular current. So I will call this again current source 1, and I can call this ammeter maybe, right? So this series combination is a controlled current source where we are adjusting the resistance and the voltage source such that we are drawing a certain current, right? And we can ensure that this current is what we want by measuring the current using this ammeter. Now, of course, all this means that we do need the measurement of the voltage as well, because in order to ensure that this voltage source produces a voltage such that it draws a certain current, I need to know what the voltage across this terminal is. So that means I will measure the voltage here as current source 1. Let me call this, what do I call this now? I would call this also volt maybe, since these are two different elements, they can have the same name, right? So this is now my controlled current source, and this controlled current source can be the resistance inductance combination, or for that matter any other load representation. So first thing I'm going to do, I'm going to save it as, and here let me go over to my machine series, simulations, simple current load, and here I'm going to choose, and here let me choose this one as current source for now load, and I'll leave this as the default. Let me close this down, go to the file browser, and open it again. This way it formats it and compresses it accordingly. So we now have a current source, or rather we have now connected a current source that is going to represent any load to our usual circuit, to the circuit before. That is, this circuit, which had a variable resistance and a variable inductance, is now going to contain this new component. That is, this component which is a variable current source. There is one small problem, and that is this ammeter is no longer needed, right? This ammeter is no longer needed, and the reason why this ammeter would have to be deleted, actually I would leave it on because then we can know this error, that this ammeter is now a part of a branch with zero resistance. So this is something we can sort out in the next lecture when we are going forward. So with this, let me quickly go over and solve that one problem. We are back to the main page. Let me go back to the main page. We have made a topological change. We have to add this new one. So I'm going to add current source load.csv. Let me call this current source representation. Save the file. And if I click on process circuit schematics, I will get an error. I'm surprised I didn't get an error. Probably I'll get an error later. That's okay. So with this, we are now good to edit the circuit parameters. We still have these load parameters, so there's nothing to change. We can only need to edit the current source representation. So now this lecture has gotten pretty long, so I'm going to end this lecture. In the next lecture, we will edit the parameters of this current source and then include it in the simulation so as to simulate a variable resistance and a variable inductance. Exactly the same simulation we did in the previous lecture. So as before, if you have any doubts, please do post either in the comments or send me an email or message me on social media, whichever is your preference. Otherwise, I will see you next week where we will continue with the simulation. Thank you so much for watching and see you soon. Goodbye for now.